Welcome to our lecture in managerial economics, where we're going to look at optimization, consumer theory, and briefly some production in the simplest manner possible. But for you to understand optimization, you need to learn how to differentiate. So differentiation, we're only going to look at what is called the power rule. The power rule of differentiation simply states that when you're differentiating y against x, you're simply multiplying the power. You multiply it to the coefficient. Okay, and you maintain the variable. So if you have y is equal to 5x by 4, your y over the x is equal to 20. So you're going to multiply the 5, you multiply it times the 4, then subtract 1 from this 4. So meaning we're going to have 20x to the power 3. This is what we call the y over the x, the letter this side against the letter that side. I want you to try now. If we had 10x to the power 7, who wants to try to differentiate?
So we multiply the 7 with the 10, it will be 7 equals dy dx equals 70. The x raised to the power 7 minus 1, it will be 6.
Excellent. So that is what we call differentiation. We're done with differentiation. Suppose we have a long 4x to the power 3. Then here we have 5x to the power 2. We have 3x. We have minus 10. Since there's a letter y this side, we're going to start with the y over the x. So this will be 12. Why 12? Because 4 times 3 is 12. Then we subtract 1 from there, we get a 2. Plus these 2 multiplied by the 5, we get a 10. And when we subtract 1 from the 2 here, it is the power 1. 1 is always invisible. Then here we already know there's an invisible 1 there. 1 times 3 is 3. 1 minus 1 is 0. So any number to the power 0 is 1, so the x falls off. The 10 has no letter, and according to this rule, whenever it is differentiating a constant, it will fall off. So this is what we call our dy dx. We're going to look at another one, TR. We have 170q minus 5q squared. TR stands for total revenue. So we differentiate what is on the left side against the letter that is on the right side. So this is called the TR over the what? The Q, because Q is on the other side. TR stands for the total revenue. Anything with a T, when you differentiate it, the T becomes M. So this is called marginal revenue and differentiate it. So 170Q, whenever the Q is the power invisible 1, just maintain the number which is there. So 170Q is 170. 3Q is 3. 10Q is 10. 90Q is 90. If it has no letter, it is a constant, it falls out. So minus 5q squared. When you multiply 2 times that one, it is 10. Then this q will be 1. We never write 1 because it is invisible. So let's try. Who wants to try to differentiate this one for us? 2q to the power 3 minus 100q squared plus 5q plus 5. Anyone to try to differentiate this for us? This will be the what?
DTR
DTR
over
DTR
DQ.
over DQ.
Okay, so this is the TR over the what? The Q.
DQ.
When you differentiate TR, it becomes what?
MR.
MR. Good. Then what is 2Q to the power 3?
It to be 6Q squared minus 200Q plus 5.
Good.
Plus
What happens to this one?
It falls off.
All right. So TR, whenever we differentiate it, it becomes what? Marginal revenue. TC is called total cost. Whenever I differentiate it, it's called marginal cost. Total profit, whenever I differentiate it, it's called marginal profit. Utility has two letters, X and Y. When you differentiate it, you have marginal utility of X and marginal utility of Y. Production has labor and capital. Whenever you differentiate it, there's a marginal product of labor and marginal product of what? Of capital. Capital is noted by the letter K. So let's try this. If we have total cost is given by 10 plus 5Q. So when differentiate it, but who wants to try? Do what? TC.
The TC, which is the marginal cost.
But the Q is equal to what? Marginal cost.
Is equal to, that will be 5.
5, excellent. All right. If you have profit, is equal to 1 over 3 Q to the power 3 plus 4Q squared plus 5Q minus 10. So this is the pi, the profit over the Q. It's a marginal profit. So when you multiply the 3 times 1/3, it is 1. We never write 1. And when you subtract a 1 from there, it's the power 2 plus 4 times 2 is 8. When you subtract 1, it's the power 1. 5Q remains 5. And when you differentiate this, it will be constant, it will fall off. Suppose we have utility, which is 5x to the power 7 and y to the power 3. We start with the u over the x. This is called the marginal utility of x. So we leave the 3 as a dummy, as it is. Don't do anything to the y to the power 3. You just deal with this 5 and x to the power 7. So 5x7 gives us what? 35x what? 6. All right. Then if you want to try to do du over dy, is the marginal utility of y. Our dummy is which letter? We're interested in the y, so x7 is our dummy. So you differentiate what remains, 5y3. 5y3, you just multiply 3 times 5 is what? 15. Then from the y, we subtract a 1, we get the power 2. We usually want to arrange them in the order where the letter which comes first in the alphabet is first. This 5 is for both of them. So I want you to try y is equal to 10x to the power 3, y to the power 5. So who wants to try du dx? Du dx is called the marginal utility of x. What is our dummy?
Sorry, I'm lost on the marginal utility y. You're saying this the x we carry it with us and we have to write it on y.
You understand as we do this other question as well. So for this one, you only understand 3 times. The first one, you all have questions. The second one, you'll be somewhere there. The third one, you get it. So du dx, so we're interested only in these two. So our y, we leave it as a dummy, y to the power 5. So what we're remaining with is 10x3. So 10x3, when you differentiate it, it will be 30 what? x2.
Squared.
Right. And if we're going to do du over dy, this is our marginal utility of y. Our dummy in this case is what? x3. So leave x3 with its power as it is. So what you're going to remain is simply what? The 30 and the what? Oh, what you're going to remain is with just a 10 and the y5. So we're going to remain with 10 y5. So when this 5 multiplies by the 10, we get 50. From the y, if we subtract our 1, we're going to get a 4. So our final answer will be 50 x3 y4. Your husbands brag that my wife is doing a master's. They don't know that you're in ICU or in BID. I'll keep that as a secret. So let's move. Let's try this one here now. 100 x to the power 4 and y to the power 8. Who wants to try to find our du dx? Du dx.
Equals, so it means that we are taking the dummy as the y8 there.
8 is our dummy.
Yes, then we say 4 by 100, 400 x, 4 minus 1, that's x cubed.
So 100x4 becomes 400x3. All right. About du dy, which one is our dummy? So this is our MUY, or the shortcut, you just put UI. Our dummy is what? X4. What are we going to remain with? 100 y8. If we differentiate 100 y8, what does it become? 800 y7. All right. So for these ones, you need to do as many as possible. Even if you had a q, q is equal to 10l to the power 4, k to the power 6. The q stands for total product over the L for the marginal product of labor. So our dummy is what? K6. What are we going to remain with? 10L4. So 10L4 becomes what? 40L3. Then if you're going to differentiate the Q over the K, this is called the marginal product of what? Of capital. So our dummy is what? L4. So what are we going to remain with? 10K6. So when you differentiate 10K6, what does it become? 60K what? K5. All right. 60K5. All right, who wants to try? Suppose we had U is equal to 2x to the power half, y to the power half. So du over dx is the marginal utility of x. So our dummy is y half. What we're going to remain is 2x half. So half times 2 is 1. We never write a 1. So you put x, subtract subtract half minus x, we're going to get negative half. When you subtract 1 minus half minus 1, go to the negative. Whenever your power has a negative, you can also leave it in the power index. Whenever it has a negative, you are punchy to become a positive, to be as follows. So it so follows that du over dy, with heat of y. So our dummy, we're interested in the y, our dummy is x half. So half times 2 is 1. We're not going to write 1. And subtract half minus 1 is negative half. So here, which letter will go down? It's a y. So this is how it will come. So this is how we differentiate. So optimization, we need to understand about 5 formulas. Number 1, our total revenue is equal to price times quantity. Meaning our average revenue, anything divided by quantity is called average. So total revenue, when you divide it by quantity, is called average. Anything differentiated is marginal. When you differentiate the total revenue, it's called our marginal revenue. Total cost is found by the total fixed cost plus the total variable cost. Again, I said if anything divided by quantity is called average. So total cost over quantity will be average cost. Our total fixed cost over quantity is called what? The T will just become an A, average fixed cost. About total variable cost divided by quantity, called what? Average variable cost. And when you differentiate the total cost with respect to quantity, this will be called our marginal cost. Any firm has 2 types of costs: a fixed cost, which doesn't depend on production, and the variable cost, which depends on production. Whenever a total cost is equal to the total revenue, we call this a break-even point. You are making a 0 profit. It's a break-even point. Profit is simply when we subtract our total revenue minus our total cost. So when a firm is producing, total revenue usually looks like that. Total cost looks like that. Total cost and total revenue look like this. So whenever our total revenue is above the total cost, we're making a profit. So here, total cost is above our total revenue. We're making a loss. So we have a loss here and a loss here. At the point where total revenue and total cost meet, it's called the break-even point. So maybe you have 2 and 5. You can advise the firm to produce between 2 and 5 units, because this way you're going to make a profit. Profit only exists when your total revenue exceeds your total cost. At this point A and B, we call this a break-even point. So to maximize your revenue, marginal revenue must go to 0. Anything marginal, you're optimizing. Optimization is simply the point at which you maximize your particular function. Okay, the price and quantity that maximizes that function. So you maximize what? Total revenue when your marginal revenue is equal to 0. When your marginal profit is equal to 0, you are maximizing what? Profit. But you don't maximize costs. So when your marginal cost is equal to 0, what do? You minimize costs. So you'd be given a function like this. Suppose the way, I have the best online lectures in the whole country. So I can't get it any better than this. So those of you who may be behind, please take time to listen to these videos. I teach every topic 3 times. So 50 plus, suppose you're given a function like this, 40 plus 50q plus 5q squared. That is your part A. Part B, you're going to try it on your own. Here we have 85 minus 2.5q. Your total cost is given by 20 plus 25q plus 2.5q squared. So part A, we're being asked to find the total revenue, find average revenue, find the marginal revenue. Part B, we're being asked to find the total fixed cost and also to find the total variable cost. In part C, we're asked to find the average fixed cost and the average variable cost and the average total cost. In part D, we're being asked to find the marginal cost, profit, marginal profit, and finally to find to maximize what? Profit and revenue. Now we're going to now use the formulas we've been looking at. So how do we find the total revenue? We say total revenue is simply price times quantity. So our price is what? 170 minus 5q. The quantity we haven't been given. Just put the letter q, you impute it. So 170 times q, we get 170q. 5q times q, we get 5q squared. So this is called our total revenue. Marginal revenue, we differentiate from what we're discussing, dTR over dQ. Can somebody differentiate for us? 170q minus 5q squared. What we have?
170q minus 10q.
70 minus 10q. 170q becomes 170. 10q becomes 5q becomes 10. And the average revenue is what? Total revenue divided by quantity. So the total revenue, we already found it as 170q minus 5q squared over q over q. So 170q becomes 170. 5q squared becomes what? 5q. So this becomes our average revenue. Okay. So let's go to our total fixed costs. So we already have our function for total cost as 40 plus 50q plus 5q squared. So our total fixed cost is simply the constant part of this. Which one is the total fixed cost? 40, without a letter. Our total variable cost is the part without a letter, which is what? 50q plus 5q squared. So the average fixed cost, we said anything divided by quantity is average. So total fixed cost over quantity. So 40 divided by quantity, that becomes our average, and I can't simplify it any further. What becomes our average variable cost? Total variable cost over what? Quantity. So this is 50q plus 5q squared. We divide by quantity, divided by quantity. What we have? 50 plus 5q. This cancels here. This here will remain with 1. So we're going to have 50 plus 5q. So before I go any further, let's go through what I said. Our price was equal to 170 minus 5q. Can somebody lead us through? How do we find the total revenue?
So total revenue is equal to our price multiplied by quantity.
What was our price?
So our price is 170 minus 5q.
And the quantity we're not given, so we impute it.
Quantity we don't have the q.
So what are we going to get?
170q minus 5q squared.
Excellent. Then marginal revenue. Who wants to try? How do we find the marginal revenue?
So we simply differentiate the total revenue function.
So we differentiate the total revenue function, the TR over the Q. Okay. So we're going to differentiate this one here. What are we going to get? $170q becomes what?
170.
5q squared becomes what?
10q.
Thank you. This is called our marginal revenue. Whenever we equate the marginal revenue to 0, what are we doing? We are maximizing the total revenue. So let's equate this to 0. Let's see. To maximize is to find what? The price and quantity that will give you the highest revenue. So we find first the value of Q. So when this one comes this side, we're going to have 10Q is equal to 170. And divide both sides by 10, our Q is equal to 17. So this Q, when you put it in the values here to find the P, we just substitute there. So 17 there, we're going to find our price as what? 85. So we have optimized. Whenever they ask you to optimize total revenue, they're asking you to find price and quantity that will give you the highest revenue. So price is 85 and quantity is 17. So So this is what we call optimization. All right. So how do we find the average revenue?
So is equal to total revenue divided by the quantity.
Okay. Total revenue divided by quantity. So what was our total revenue?
It's 170Q minus 5Q squared.
So 170Q minus 5Q squared. So caution here, if you put 1Q there, people will just forget. They don't divide there. That's why I usually tell students to divide the Q across the board so that you're able to find our value. So when you divide it, you're going to get 170, and here you're going to get 5Q. This is how we find the value there. Any questions this far? Any questions this far? Okay. So this is what we call optimization. There are some calculations that are a little bit messy in this topic that you need to really understand. I will plead that you really take keen interest in going through the video that I have. Some of you here will need to join the special class because I'll need to quarantine you so that I will take you more like babies. But some of these things are inevitable. I'll need to cruise a bit for you to understand. So these are the computations that you're looking at. So before I go any further, I'll also explain perfect market that surrounds this kind of computation. So we have markets where buyers and sellers trade. So we have what is called a perfectly competitive market, where there are many buyers and sellers. In this kind of market structure, goods are homogeneous. This means the goods are identical. The prices are set by the invisible hand of demand and supply. So demand is actually your price. So in a perfectly competitive market, the goods are very identical, they're the same. In this market structure, there's perfect information. Everyone knows how much the goods are selling for. So it's free mobility of the factors of production. And so why I want you to know this, because these computations come from these different market structures. So the perfect competition has many buyers and sellers, and the average size of each firm is relatively small. The nature of the product is the same. identical. So the more sokoni market, you will not differentiate tomato that has what? Manure and the tomato that they are not packaged. In short, there is no barriers to entry. Anyone can move in and leave whenever they feel like. Government intervention there is 0. Then there are no output restrictions. You can produce as much as you can, and each firm is independent. They make low profits in the short run. A profit maximization occurs when our price is equal to the marginal revenue, since the price is actually what we call our marginal revenue. So the implication of the curve, it is horizontal, as I've shown you. So the curve looks like this. Marginal revenue is your demand. So this is what happened in this market structure. Goods are identical. Examples are vegetable farmers, dry cleaning businesses, and groceries. So the function, the curves look like this in a perfectly competitive market. Marginal revenue cuts in between of the average total cost. And the other market structure which you need to know is a monopoly. Monopoly like Zesco, where there's only one major seller or supplier of the product. There are heavy barriers to entry to prevent competition, right? Monopolies can come natural or geographical, or because of technological advancement, or government monopoly. So the curves look like this. For a monopoly, the demand, the marginal revenue is half of the average revenue. This demand is our average revenue. As usual, the marginal revenue cuts in between our average total cost. So where the marginal revenue and the marginal cost meet, that's where you maximize profit. So marginal revenue and marginal cost, they meet here. You draw your line there, where it meets the average total cost. So this is what we call the abnormal profit. So when we're talking about monopoly, said there should be what? One major seller. These firms are very large. The goods that they produce should be unique. There are heavy or significant barriers to entry. There's government intervention. Most output restrictions exist there. The government will control how much will be produced, and there are no competitors there. They make abnormal profits in the short run, and their demand curve is downsloping. Profit maximization occurs when the marginal cost is equal to marginal revenue. So these ones are called price setters because they set the price. Then we go to what are called oligopoly. In an oligopoly, we have two or more firms which form what is called a cartel or collision. Their size is relatively high, and they produce both identical and differentiated goods. The barriers to entry here are also heavy or significant. Government intervention is quite existent, and there's output restriction. Decisions here are interdependent. Good examples are OPEC countries, where they are going to determine how much we produce to which country in what quantities. Also, a demand curve is kinked. It's an ugly demand curve which looks something like this. This is a kink where they have what we call the marginal revenue gap. Because decisions are interdependent, when they all agree to say we're going to sell at 5 kwacha. If you decide to sell at 6 kwacha, they'll leave you. If you decide to sell at 4 kwacha, they'll go below you to put you off the market. They'll sell at 3 kwacha. They know you cannot go below them because you make a loss. So this is the kink that makes decisions interdependent. So an oligopolistic market structure is very important. So we have very few firms that dominate the market. McDonald's, Wendy's, right? So these are price setters. They form a collision, which makes an agreement between these organizations. They say we're going to sell so much. Of course, in these, there are what we call market leaders, like Nigeria produces so much oil, so they will be dominating a particular market. And finally, we go to what we call monopolistic market structure. In monopolistic market structure, there are several firms. Trade Kings is one of them, or restaurants. These ones differentiate their products. They undertake a lot of marketing and product differentiation. They are free to enter and exit the market. So product differentiation exists where products of the same industry want to make their own signature. For instance, we have Colgate against normal toothpaste. Up to now, people think toothpaste is Colgate because of how these people marketed their products. All right. So in a monopolistic market, there are many firms, SMEs, small to medium enterprises, goods are differentiated, a few barriers to entry. They have some power over pricing. There's no government intervention, output is restricted, and each firm is independent. The pricing making possibility is medium. The demand is downsloping, and profit is maximized when marginal revenue is equal to the marginal cost. Brings us to another key principle which we need to learn, which is called elasticity. Elasticity is simply a responsiveness that exists due to changes in what? Demand. So elasticity is a very key, important topic in managerial economics because it looks at how you and me react to prices, changes in prices. Women are more elastic than men because you people are so keen to knowing or finding out what price a commodity is going for. For men, we can buy in any quick shop without thinking twice. When the women see the bill of 500,000 or 500 kwacha, they could get it from as low as 250 or 200. So elasticity basically looks at the responsiveness that consumers have towards what changes in prices. So we discuss the factors that affect demand in the other class. So these factors that affect demand are the ones that we're going to now get in this lecture to help us understanding factors that affect elasticity. So elasticity of demand is affected by the factors that affect demand. So if I were to ask, what are some of the factors that affect demand? Demand is affected by a number of factors. What are some of the factors that affect demand? Number one,
Its own price.
Its own price. Number two,
Price of a substitute.
Okay, price of a
or
substitute.
complement.
Okay, a price of a related good, yes. Price of a substitute. Price of a related good can be substituted or a complementary good. What else? Income.
Income.
Yes, so among others, we have factors that affect demand like what? Population, advertising. We also have taste. We also have weather. We also have expectations. There are many, but for now, we'll concentrate on these factors that affect demand, because these are the ones that also affect what? Elasticity. So, and dealing with the price that affects that particular commodity, we call that price elasticity of demand, PED. Price elasticity of demand is simply the percentage change in quantity demanded over the percentage change in what? In the price. That is price elasticity of demand. If you're using calculus, it is TQ over TP times price over quantity. That is elasticity of demand. Now, we can also use a very linear example where you're going to multiply B times price over quantity. Elasticity of demand ranges between the following values: between 0, 1, -2 going upwards. So if it's between -1 and 0, we say it is inelastic. If it's exactly at 1, we say it is unit elastic. If it's more than 1, we say it is elastic. So elasticity of demand is always negative. You can't have a positive. So between A, B, C, and D, I need you to tell me which one is elastic, which is inelastic. 0.9, -1.7, -1.0, -24. So what is A, elastic or inelastic? A is what? Quickly?
Inelastic.
Inelastic. Anything starting with 0 is inelastic. About B?
It's elastic.
Elastic. It's more than 1, yes. About C?
It's unitary elastic.
Elastic. How about D?
Elastic.
Elastic. It's very elastic, yes. So at least you have an idea of what elasticity looks like. So now, if you're given a function as follows, quantity is equal to 10 minus 2p. The price is 4 kwacha. Let's calculate the elasticity. So firstly, we need to substitute this 4 in here to find the quantity. So what do we get when we put our 4 there? What becomes our quantity? 10 minus 8. Our quantity is equal to what? 2.
That's 2.
So elasticity of demand is equal to -b times price over quantity. So this -b is a number that comes before the letter here. So our b is what? -2 in this case, or 2. So to calculate the elasticity of demand, -2, the price is what? 4, and the quantity is what? 2. So when this and this cancels, we're going to get -4. So the demand here is what? It
It's
is
elastic.
elastic. So also you need to understand that sometimes when P is given a subject of a formula, 10 minus 2Q. If P is subject, we call that an inverse demand. So elasticity of demand will be slightly inverse. Inverse means 1/4, 1 over that number. So 1 over B there, it will be inverse times price over quantity. So suppose in this case we're given our quantity as 1. So when we put our 1 there, our price will be what? 10 minus what? 2, which is 8. So the letter which comes, the number which comes before the letter is our B. So in this case, our B is what? 2. So to use this formula, we're going to get -1/2, and the price is 8. The quantity is 1. So when you multiply, we get 8 there. When you multiply, we get 2 there, negative. So here we get -4. It's still elastic. All right. Suppose our quantity was actually
Repeat the concept of the inverse there.
so the inverse is when P is subject to a formula. When the Q is subject to a formula, it's simply the direct demand. We don't put 1 over. Okay.
So whenever they've started it with a P, we need to regard it as an inverse.
Yes. So the demand function is given by A minus BQ. This is called the inverse demand function. But if it's given by direct demands A minus BP, this is called the direct demand function. So if the demand function is given by P, the formula for elasticity of demand is what? -1/B times price over quantity. If the function is given as follows, elasticity changes will be negative B times price over quantity. Right. So this is with regards to price affecting your demand. What else also did we say affects your demand? The related goods. We have two related goods that we've talked about. Number one, the complementary good. What's a complementary good? Complementary good is a good which has what? A complementary usage. Example, tea and what? Sugar.
Sugar.
Phone and what? SIM card.
SIM card.
So the elasticity of demand for a complementary good is always negative, because if the price of one good goes up, the demand of the other good will go down. So complementary goods are goods with the same usage. And when we go to substitute goods are goods with the what? Competing usage. Examples are what?
Bread and bun.
Bread and bun, good. What else?
Tea or coffee.
Tea or coffee, good. Holding all things constant. I'll say no, this has caffeine, but all of them are working the what? Same usage. These are called substitute goods. So these ones always have a positive elasticity of demand. We also have income. Income is what is called the income effect. The letters that denote income are letters M or I or Y. So for cross price elasticity, we use EXD, cross price elasticity of demand. Income elasticity of demand, we use YED, income elasticity of demand. So for income, naturally, it is expected that the higher the income, the more you demand of that particular good. However, there are a few exceptions. So if the good increases in consumption, when your income goes up, we call that a normal good. But of these normal goods, we have what we call a necessity. A necessity is a good whose elasticity of income is between 0 and 1. A luxury good, it goes above 1. But an inferior good is one with a negative elasticity of income. Inferior goods are goods which we demand less of. If your income is going up, for instance, Salaula clothes, maybe low grade or coarse salt, you want to use fine salt, designer clothes, cars as well, the higher the income, right? So if your income elasticity of demand is positive 2, that is a luxurious good. If your income elasticity of demand is 1.2, that is a necessity. If your income elasticity of demand is negative 1.2, that is an inferior good. So this is how it goes. For cross price elasticity, if your income cross price elasticity of demand is negative 2, it means that's a complementary good. If cross price elasticity of demand is positive 2, that is what? A substitute good. So sometimes you'll be given a multilinear equation where you're told that suppose the demand equation is given by 2 minus 4px plus 5py plus 10m, and we are told that the price of x is 2 kwacha, price of y is 3 kwacha, and the income is 5 kwacha. But A, find your annual demand. So to Find the annual demand versus or the current demand, just substitute the figures there. 2, where there's px, we put 2. Where there's py, put 3. Where there's income, you put your 5 there. All right, so our Q here will be 2 minus 8 plus 15 plus 50. All right, so this is minus 6. So this is 65 minus 6 is what? 59. So this is your current demand. In part B, find your price elasticity of demand. Since I've given you a direct demand Q subject, so just do, okay, negative B times price over quantity. X against X means on price elasticity, dealing with this on product. So what is the gradient for the good? -4.
-4.
And the price was given as what? 2.
2.
And the quantity we just calculated it as what? 59.
50.
So this is -8 over 59. What we get? Compute that. 8 over 59.
0.136.
And it is 0.136. What is your comment here? Demand is what?
This is inelastic. It's less than 1.
Then at C, they ask you to find the cross price elasticity of demand. So here, cross price elasticity, B times what? Price of Y over good X. So our B here, on this one here, the commodity. If you're dealing it against itself, this is on price, it's on product. But if it's crossing from X to Y, it's cross price. Whenever these letters have different signs, you're able to tell that these are what? These are substitute goods. They're competing against each other. But whenever the signs are the same, there's negative here and there's negative there, they're complementing each other, they're complementary. That's one sign. Anyway, we can go. What's our price there? 5. And what is the price of Y? 3. And what is our Q? 59. So here we're going to get 15 over 59, which give you
0.25.
0.25. So what's your comment?
For cross
Yes, for cross price elasticity, we say they're substitute. Don't it's inelastic or here just substitute or what? Complementary good. So because the sign is positive.
Positive is a substitute.
Yes. Then finally, we go to the income elasticity of demand, or YED. Okay. So our B times the income over the quantity. All right. So what is the gradient here? Gradient here is what? 10. Our B is 10. Then our income 5 over what? 59. So this is 50 over 59 gives us what?
0.85.
85. So what kind of a good is this?
On the income, that means
it's a necessity. All right. It means it's a necessity because it's been 0.
Within the range of 1. Yeah.
Yes. All right. So not all of these ones are what? Not all of these ones are calculus related. So this is basically what we're discussing. Categories, okay, calculating the elasticity of demand. Then also we just looked at one example here. This example we're given in this tutorial sheet was as follows. Okay, so we're told that this tutorial sheet here school. Daily demand of shoes is estimated to be 100 minus 3 py, this and that. So we're told that the price of good y, price of x is 25, price of good y is 35, and advertising 50 units, and the income is 20,000. So firstly, we need to find the what? Current demand. So where there's px, we're going to put 25. Where there's py, we're going to put 35. Where there's income, we're going to put 20,000. Where there's advertising, we're going to put 50 units. So when we substitute that, we are going to have 65 units as the current demand. So to find the on price elasticity, we get the gradient for x, which is -3, then 25 out of the total. So -3, 25 out of the 65. Here we get what? -1.15. What is our comment here? Demand is what? Elastic. All right. Go to the next one. We're going to get the 35 over the 650. So firstly, we identify the what? Our coefficient -4, +4. So +4, 35 over 65. We get +2.15. So since it's positive, we can say it's a substitute good. And finally, we go to the income, -0.1. Okay, as a coefficient, and 20,000 over 65. -0.5, 20,000 over 65. We get -3.08. Because the negative, what kind of good is this? We say it's an inferior good. So the tutorial sheet number 3, which was sent to you in class, I need you to try the exercise that was given at the end. I require these at the end of before midnight today. The other group managed to answer them within 5 minutes. So any questions so far?